All right, so today we're going to start off a new section. This is chapter 8, okay? And it has to do with the arithmetic sequences, okay? Like I said, some people call them arithmetic sequences, arithmetic sequences. I'll kind of switch back and forth. Sometimes I do call them arithmetic, sometimes I'll call them arithmetic. It sometimes just flows out of my mouth a different way. So if you hear me say arithmetic or arithmetic, it's the same thing. But we're going to be talking about sequences. Now, arithmetic sequences and geometric sequences are a little different. A lot of times when it comes down to the geometric ones, we talk about the common ratio, which is how it multiplies over and over. For us, it's arithmetic, which means it either adds or subtracts consistently. Okay, so we'll get into that right now. But first off, what is a sequence? So a sequence is just a list of numbers, okay? So a sequence is a list of numbers. Okay? It doesn't have to be a list of numbers that are in any kind of particular order. Okay? But I mean, we could say like 2, 4, 6, 8. That could be a sequence. Negative 10, negative 13, negative 16, negative 19. Can be a sequence. Okay, now just so that you guys know, those 3 dots after, those are called ellipses. Those 3 dots means it keeps going. So sometimes you might see those ellipses at the end of the number. Sometimes you might see them in the beginning. Sometimes you see them on both sides. So for example, something like this, like dot dot dot, negative 2, negative 1, 0, 1, 2, dot dot dot, right? Meaning like there's numbers before it and there's numbers after it. Okay, but I'm just showing you a little bit of that sequence, right? Negative 2, negative 1, 0, 1, and 2. So the ellipses are going to be used in this lesson sometimes to show you like there's more stuff after that, but it doesn't matter, right? We're just focusing on the stuff that I'm showing you. But in my case, I showed you one of them that had before and after, and then 2 of them that had afters, right? So the first 2, you can see the ellipses at the end of the commas, right? Whereas the last one I gave you, it was before and after. So there's numbers before it, there's numbers after. Whereas in the first 2 sequences, 2 was the starting number. That was the first term. And then came 4, 6, and 8. And on the next one, negative 10 was the first term. And then negative 13, negative 16, negative 18. Whereas in this last one over here, the negative 2 is not considered the first number. There's numbers before it. Right? So that's what that means. Like negative 2 is not the beginning number. That's just one of the numbers. But there's numbers before it. And then 2 on that same sequence is not the last number. There's numbers after it. Okay? So again, those ellipses just mean that there could be stuff in front of it or stuff after it. Okay? So what is a sequence? Well, a sequence is a list of numbers. Well, what's an arithmetic sequence? It's when the list of numbers has a common sum or difference between them. Okay? So I'm going to put right here, when a list of numbers, I'm going to put in parentheses a sequence, has a common sum or difference between each number. So when a list of numbers, or when a sequence has a common sum or difference between each number. So if you look at the sequences I put on the top 3 up there, right? 2, 4, 6, 8. In order to go from 2 to 4 to 6 to 8, I had to add 2 every time, right? 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So that I had to add 2 every single time to get the next number. That would be considered an arithmetic sequence. The next one, negative 10, negative 13, negative 16, negative 19. In order to get that list of numbers, I subtracted 3 consistently, right? I didn't add, I subtracted. Subtracted 3. So negative 10 minus 3 is negative 13. Negative 13 minus 3 is negative 16. negative 16 minus 3 is negative 19. Okay, so that's going to give me that list of numbers. Okay, so that would also be an arithmetic sequence. Okay, so how do you know it's not an arithmetic sequence? Well, when it doesn't add or subtract the same every time. Okay, now with this common sum or difference, they actually do have an actual term for it. They call it the common difference. Even if you add, it's still called the common difference. Okay, so I'm going to put that in green. We're going to define it a little later. But the common difference, the number that you either add or subtract consistently, we're going to denote it by the letter D later on, okay? So right now we're not going to do that. Well, it'll show up, but it's not going to mean anything yet. We're going to write it in a formula near the end of the lesson, okay? But that number, whatever it happens to be, so like I said, from 2 to 4, 4 to 6, 6 to 8, I always added 2. So that value, D, would be equal to positive 2 right there. Down here, to go from negative 10 to negative 13 to negative 16 to negative 19, it was always minus 3. So that means that for this one, D would be equal to negative 3. Up here, D would be equal to 2. All right? So you're going to want to denote that. If it's an actual arithmetic sequence, tell me what the value of D is. Okay? Because that's actually an important value. So let's go to the first examples here. Now on your homework, unfortunately, I forgot to erase a certain part of the instructions, because in the instructions it says, are these arithmetic, geometric, or neither? And we used to teach both at the same time, and I forgot to get rid of that. It's just supposed to say, are these arithmetic sequences, yes or no? So I'll remind you guys right now when I give you the homework, okay? So all you have to do is tell me if this list of numbers, if these sequences are arithmetic sequences. Now remember, what makes them arithmetic sequences is that they have a common difference between each number, okay? Or a common sum, but they always call it a common difference. Whether you're adding or subtracting, it's referred to as a common difference. So is it always the same number? So you're going to look at part A right here. We have negative 1, negative 2, negative 6, negative 24. So to go from negative 1 to negative 2, what do I have to do? It's minus 1. To go from negative 2 to negative 6, what do I subtract? 4. Well, let me just do the rest of these right here. This would be minus 18. And this would be minus 96. Okay? Are those all the same? No. So then you're just going to write, no, they're not. It's not an arithmetic sequence. Okay? So we look at part B, 18, 21, 24, 27, 30. So from 18 to 21, what do I do? I add how much? 3, right? And what about 21 to 24? 3. And 24 to 27? Also 3. And 27 to 30? Also 3. So I'm going to write yes, and then at the same time, not that you have to, but I think it's a good thing that you get in practice of doing this, write down your common difference, okay? So you added 3 every time. So you're going to have like 6 problems like that in the beginning of your homework where they just want you to tell them like, are these arithmetic sequences, yes or no? If they are, you don't have to, but I do recommend you put the common difference there. D equals whatever, right? 10, negative 3, 5, whatever it happens to be. So that's pretty easy, right? Just identifying these sequences. Now, before we get into example 2, how we label terms, okay? So how we label some of the terms. So, you'll notice A sub n is the nth term. Okay, A sub n, if you ever see it, it's called the nth term. The nth term means you tell me which term you want, and I'll try to find it for you. So if you want the 10th term, I'll write A sub 10. That's the 10th term. Okay? Or if I write a sub 2, that's the second term. All right, a sub 1 would be the first term. A sub 100 would be the 100th term. Okay, so whenever you see like lowercase a's with a subscript on it, that little number on the subscript, that's just telling you which term we're talking about. Okay, so like I said, a sub 1, that's probably going to be one of the most important ones. That's the first term. And then we already discussed the value of d, right? D is our common difference. So I just want to make sure you guys are aware of how that works, because right now we're going to get into some problems where they're going to use that notation. So you have to understand what it is that they're writing. Okay? So a sub n is the nth term. It depends which number you want to put in. You want to put a 20, then that's the 20th term, right? A sub 20 would be the 20th term. A sub 50 would be the 50th term, etc. By the way, n does not become negative, so you can't find like the negative 5th term. Okay, you don't do like a sub negative 5. It's only from 1 to the positives. Okay, so all right. So here's example 2. Given the first term and the common difference of an arithmetic sequence, list the first 5 terms. So they're saying, look, we gave you the first one. We told you by how much they differ. Can you write the next 4? So I'm going to put this right here. 1, 2, 3, 4, 5. All right, now the first term is negative 8, so I'm going to put that in the first place. And I know my common difference is 5. Notice it's positive, that means I'm adding it. Okay, I'm adding it. If it was a negative, that means I'd be subtracting it. So negative 8 plus 5, that's negative 3. And negative 3 plus 5, 2. 2 plus 5, 7. 7 plus 5, 12. There you go, you're done. Okay? They're going to give you the first term and a common difference. The common difference, if it's positive, that means add it. If it's negative, that means subtract it. Okay? And just keep doing that consistently until you fill in all the spaces they need you to fill in. That one pretty easy, I hope. So far, hopefully nothing too crazy, right? All right, we'll switch it up a little bit. Okay, it says given the second term and the common difference of an arithmetic sequence, list the first 5 terms. So 1, 2, 3, 4, 5, and I know the second term is 10. And so I'll just give you a little bit of time because I know some of you guys are trying to write down the instructions. So let me give you a little bit of time for that. But again, I'm giving you the second term, which is 10, and the common difference, which is minus 5. List the first 5 terms. So I only know the second term so far. So how do I find the next term after 10? Subtract 5. Yeah, so it's going to be what? 5, and then what's next? And then, how do I find the first term? I just do the opposite, right? I'm going to add it. Instead of subtracting, I'm going to add it, so it's going to be 15. Again, not a hard thing to do. It's just think about it a little bit. I think the scariest problems are going to be example 4. Just because they look scarier than the other ones. But they're not that hard to do. There's a way to do it. Are we okay with the first 3? Yeah. All right, so example number 4. Example number 4 says, find the missing terms in each arithmetic sequence. Okay, so notice they gave me negative 19. They gave me an 81. You notice there's ellipses in the front and in the back. The 3 dots. right? There's dots in front of it. There's dots in the back. So is negative 19 my first term? No. The first term is somewhere before that. We don't know what it is, but it's somewhere before negative 19. And 81 is not the last term. That's just towards the end of it, but it doesn't mean it's the last one. So those ellipses basically don't allow me to say, okay, a sub 1 is negative 19. That's not true. The first term is not negative 19. Okay? My job is to fill in those spaces, and they got to be equally distanced because this is an arithmetic sequence. That means I got to add the same number or subtract the same number every time. Okay? So how am I going to do this? So what you're going to do is you're going to get the first number you see and the last number you see, and you're going to subtract them. Okay? So I'm going to do 81 minus negative 19. Okay? I'm finding the range of those numbers. Okay, in other words, like how far away are they from each other? So this basically becomes 81 plus 19, which is 100 and how much? It's 100 exactly, right? Yeah. So it's 100. All right. That's my range. To go from negative 19 to 81, it's 100 values. Now, I got to get this number and I got to divide it. Okay? And I have to divide it by the number of steps that it takes for me to get from that first number they gave me to that last number they gave me. So, from negative 19 to this blank spot, that's 1, 2, 3, 4, 5 steps. It takes 5 steps. So I'm going to put it right here. 5 steps. I'm just putting this so that you can see it when you're looking at the work. All right, so it took 5 steps to get there. So what I'm going to do is I'm going to get my range and divide it by the number of steps, and that's going to give me my common difference. So if I get 100 and I divide it by 5, that's 20. This is my common difference. That's how much they're differed by. Okay, or how much they differed by. All right. So if I know that my common difference is 20, then I can fill in the rest of these numbers. So negative 19 plus 20, 1. 1 plus 20, 21. 21 plus 20, 41. 41 plus 20. And then just to make sure, 61 plus 20, 81. Okay? So that means I did it right because I went from negative 19 to 81, adding or subtracting the same number consistently. And it went from the first number to the exact last number. Right? I didn't end up at 85 or something like that. I'm supposed to get to 81, which I did. Okay? All right, so remember, find the range, count the number of steps, and then divide the range by the number of steps. And that'll give you your common difference. All right, so last example's coming up. So the explicit formula of an arithmetic sequence. It looks like that. A sub n is equal to the first term plus n minus 1. That's the term minus 1, whichever term you want. 10th term, 20th term, whatever. But the term minus 1 times d. Okay? So again, n is the term we want. A sub 1 is the first term. And d is the common difference. Remember, just because it's called a common difference doesn't mean that we have to subtract. Like you might add, you might subtract. Okay? So n is the term we want. A sub 1 is the first term. D is the common difference. And the formula is that up there. Make sure you guys memorize it. Okay? There's going to be another formula that we're going to memorize later, which is a sub n equal to, I think it's a sub 1 times r to the n minus 1, the geometric one. So we'll do that one too. You have to know those. Make sure you memorize. All right. So they're going to give us some examples or some problems in your homework where they say, look, we're going to give you the information you need. Write out this formula with the information we give you. You don't have to do anything special with it. They just want you to write it out. Okay? So let me show you what we're talking about. And they'll give it to you in two different ways. Okay? I think two problems are like part A and two problems are like part B. So it says, find the explicit formula of the arithmetic sequence. You know what? I'll write the formula up here since we don't see it in front of us. A sub n is equal to a sub 1 plus the quantity n minus 1 times d. Just as a reminder. So find the explicit formula of the arithmetic sequence given that. This is the last example. Once we get done with this, I'll give you guys a homework and you guys can work on that. So notice for part A, they gave me a sub 1, they gave me d. N does not have to be given. N is whatever they ask me to find eventually. They might say like, hey, now that we filled out the formula, find the 10th term, find the 50th term. Okay, so N doesn't have to be given, but a sub 1 and d, we have to either find it or they're going to give it to us. So for us, they gave us a sub 1, they gave us d. So notice a sub n is equal to a sub 1, which is 3, plus n minus 1 times d, which is 2. And that's it, you're done. Okay, some people like to go a little further, and I'll kind of show you, but this is all that needs to be done. But sometimes, like some books, when they show you answers, or like sometimes in the state test, this is what they'll do. They'll continue, they'll distribute that 2, and then write that as that formula. Okay, 2n plus 1. Which is actually, I don't know if you can tell, but that's the slope-intercept form. The slope of 2, intercept of 1. Okay? Sometimes they like to do that on state tests. So just be aware if you're doing a state exam and you wrote your formula and it looks like that, and you look at your multiple choices and you're like, I don't see it, right? It might mean that they distributed the d value in and then simplified it as much as they could. All right, so just know that can happen. All right, I don't need you guys to do that for me. But that's something sometimes the state exams will do. So last one right here. For part B, negative 38, negative 138, negative 238, negative 338. This is a sequence, right? It continues from there on. Now, they didn't explicitly give me a sub 1 and d, but they kind of did, right? What is my a sub 1? Negative 38. That's the first number mentioned. Notice it doesn't have ellipses in front of it. That means that there are no numbers in front of it to the left. Okay? So negative 38, that's my a sub 1. What's my common difference? It's 100, but negative, right? Negative 100. I think I heard someone say it earlier. But I wasn't too sure. But it is negative 100, right? To get from negative 38 minus 100 is negative 138. Minus 100 again is negative 238, etc. So there's my a sub 1. There's my d value. So let me just write it out. A sub n is equal to a sub 1, so that's negative 38, plus n minus 1 times negative 100. All right, and that is the correct answer for us here. Again, if they want you to simplify it, just distribute the negative 100 in, simplify it from there, and you're good. But I'm not going to make you do that. Just write it out in its explicit form. Are we okay with those two? All right, so let me give you guys a homework. If you guys have any questions, let me know. Go ahead. For the instructions? Okay. All right. Let me pause it here and give you guys your homework.